Hi, hello everyone. My name is Michael Gomez from Fairfield, New Jersey, and I'm a current student at Bergen County Academies. And my research project focused on skin pigmentation, um, which is a relevant area of study right now, considering that we live in a society that ties self-worth and self-image to our physical appearance. And so because of that, skin pigmentation has a psychological component to it. Also, considering that we live in the middle of a pandemic, a lot of us have developed acne as a result of wearing masks all the time. And acne can lead to scarring and hyper or hypopigmented areas on our skin. Although there are treatments to treat pigmentation conditions, a lot of them have limitations to them or drawbacks to them. So it's important to develop and discover new and alternative therapies for pigmentation conditions. And so pigmentation is a result of melanin production. Melanin production is a very dynamic process. There are a lot of moving parts to it. However, the most important aspect of melanin production is the enzyme tyrosinase. If you affect tyrosinase, you affect melanin production. And so tyrosinase is activated by this enzyme called protein kinase C beta, or PKC beta for short. And PKC beta is activated by calcium. And so because of this, calcium serves as a regulator of melanin production. If you increase calcium, you increase melanin production, and if you decrease calcium, you decrease melanin production. Also, a lot of the events that are associated with melanin production are also associated with inflammatory processes. And so because of this, my project looked at the connection between pigmentation, calcium concentration, and inflammation. And so I looked at the inflammatory pathway called the arachidonic acid pathway, which is responsible for creating a variety of inflammatory mediators. So arachidonic acid can be metabolized by two enzymes, and the one my project looked at was cyclooxygenase 2, or COX-2 for short. And so metabolization of arachidonic acid by COX-2 leads to the production of prostaglandins. And one specific prostaglandin, PG2, leads to a whole cascade of events that leads to an increase in calcium. So I suspected that if I could inhibit this enzyme, COX-2, I could decrease PG2 production and decrease calcium concentrations and decrease melanin production. And so I decided to look at the COX-2 inhibitor, celecoxib. It's an FDA-approved drug. And so I hypothesized that treatment with celecoxib would lead to a decrease in melanin production. However, celecoxib also binds to the protein endoplasmic reticulum calcium ATPase, or ER calcium ATPase for short. And the literature suggests that when celecoxib binds to ER calcium ATPase, there's a leakage of calcium from the endoplasmic reticulum into the cytosol, increasing calcium concentrations. So I hypothesized that celecoxib could also be used to increase melanin production by increasing calcium concentrations. And so my research project decided to look at these two opposing hypotheses, since there are two potential mechanisms of action by which celecoxib could act. And so I found that in low dose, high dose effect, at lower doses, celecoxib decreased melanin production, whereas at higher doses, it increased melanin production. And so because there was this difference in melanin production across low and high dose, I suspected that celecoxib was acting differently at lower doses than it was at higher doses. And I suspected that it was doing this through the different calcium pathways that I mentioned earlier. And so to corroborate this hypothesis, I looked at celecoxib's mechanism of action. High-dose celecoxib, which increased melanin production, also increased tyrosinase activity. And I did not get to measure low-dose celecoxib because the week that I was performing the assay, my school shut down and I couldn't do it. But I do suspect that tyrosinase activity at low dose would have been lower than a control compared to the control. And so because of my school shutdown, I had to adapt as a researcher, and I looked into bioinformatics tools and computational modeling, and I used publicly available data sets. And in doing so, I found that high-dose celecoxib in cardiomyocytes increased the gene expressions, the expression of genes in pathways related to melanin production and calcium homeostasis. Whereas low-dose celecoxib in adenocarcinomas led to a decreased expression of genes involved in melanin production and calcium signaling pathways. So overall, my research suggests that celecoxib acts as a potential therapeutic drug to treat hypo or hyperpigmentation conditions, and the low-dose effect, and my research also suggests that the high-dose low-dose effect is a result of the different mechanisms of action by which celiac could go through. And that's dependent on the calcium pathways that it affects. Thank you so much for watching. It's been a pleasure.